Okay, so for graphing our higher order polynomials, we're gonna need to, just like factored form, plot the x-intercepts. So we're gonna factor and use the zero product property and the y-intercepts. So we'll have these key features. Then we need to sketch the arrows for the end behavior. And that changes based on the degree, which is the highest exponent, being odd or being even, and then the a value being positive or negative. So no matter what, we'll be in quadrant 1 if the a value is positive, even if it's odd or even if it's even. And so that's quadrant 1. But for odd, the arrows point in the opposite direction, whereas in even degree, the arrows point in the same direction. So for positive, they both point up, and for negative, both of the arrows point down. But for an odd degree, they're always opposite. So it's quadrant 1 for positive, but then you'll see quadrant 4 for negative, and so the arrows will be in these two. We express this by saying which way the arrow goes. So on the negative infinity side of the x-axis, the arrow's pointing down, and that's why we said negative infinity here. But on the positive side of the x-axis, the arrow's pointing up, and that's why we said positive infinity here. So then we'll see just the opposite for this one. We'll see that on the negative side of the x-axis, the arrow's pointing up, so we say positive infinity, versus on the positive side of the x-axis, the arrow's pointing down, and so we say negative infinity. For the even, we see they're both pointing up, so these are positive infinity for both of them. But then when the a value is negative, they're both pointing down, and so we have negative infinity for both of those. So in order to plot these, we start by plotting the x-intercepts and the y-intercept. We draw the arrows, and then we're gonna sketch the graph. Something to note is that the x-intercepts, if it's a degree of 1, would just look like a line. But if the x-intercept has an exponent of 2, like this one does, you're gonna see that x-intercept look like a parabola. And if it has an exponent of 3, then it would kind of look like one of our cubics. You can see we're combining all of those shapes that we've learned in the past into one massive function. So here's our first example. We can see that the equation says negative, so we know the arrow will be in quadrant 4. And then we see there's an x minus 5, x plus 1, and then this one has the exponent of 2. So we see that the a is negative 1, and the zeros, or the x-intercepts, are 5. 5 minus 5 is 0. Negative 1 plus 1 is 0. And positive 1 minus 1 is 0. But this one has the exponent of 2, so we say multiplicity of 2. We did the math up here to find the y-intercept. That's plugging in 0. And remember that negative 1 squared would be positive 1, times 1 is still 1, 2 negatives, so we get 0,5. To find the degree, right, that's gonna be the highest exponent if it's in standard form, but this one is in factored form, so we have to multiply. So this one counts as 2, 1 more, 3, 1 more, 4, so the degree is 4. The number of turning points is always the degree minus 1, so it's 3 this time. And so we're going to use the degree being 4, which is an even number. The a value is negative, so both arrows point down, so we have negative infinity for both, and that's what we have here. To sketch this, I draw the arrows, the x-intercepts, and the y-intercept. And then this one is already graphed, so what we do is we start at the arrow and we go up to the y-intercept. Here, we drew the hint that it was going to be a bounce, and then that means we don't cross through the x-axis. This looks like a vertex, and then this one looks like a line. So if I zoom in here, it's like a line. If I just like kind of cover this up, it looks like a parabola. And then this one is, if we look just in between my fingers, that looks like a line. And so why? That's because this one was multiplicity of 1, this one was multiplicity of 1, and this one was multiplicity of 2. So that's where we see that vertex. Our second example shows a polynomial that needs to be factored. So you can see I took it right to the box. Factored this x squared minus 9, oh, that's x plus 3x minus 3, and then the x plus 4. So this meant that none of these had an exponent of 2, so then you're going to see our picture look a little different. The zeros are at -4, -3, and +3. And the y-intercept, in this case standard form, shows you the y-intercept, it's -36. Standard form shows you the degree, it's 3. We don't need to add them up, meaning the number of turning points is 2. And the A value, we don't see anything as a negative, so that means it's 1. So again, our A value being positive, odd degree, we're in quadrants 1 and 3. So on the left side, we're at negative infinity, and on the right side, positive infinity. So that's what we're seeing here. So we draw our arrows, and then we plot our x-intercepts. The y-intercept, we can just say where it is. It needs to be on the correct side, but we'll scale that y-axis. And you can see each one we just went through, and there was nothing special. There was no bounce because none of these had an exponent of 2.